Hey guys, it's Dr. Conklin. I'm here to do a review video for you on circles. I'm here with my good friend Victor. Hello everyone. He's a Brachiosaurus. And of course, hey, Lullaby, what's up with the shades today? Too cool for school, I guess. All right, so I'm going to sort of zip through this and you'll have an ed puzzle. So you have questions, so back it up. Victor, back it up. So if we look at the first question, we're going to start by reviewing central angles. So I actually added a little part in here to review with you. First, if we're asked to find QT is actually a semicircle in this picture. So the measure of QT is simply going to be half a circle, which is 180 degrees. And then I actually wanted to review with you guys RT as well. So RT actually covers sort of two minor arcs, two shorter arcs. If you look at these arcs, you can see that we know this part is 50, but we don't know this, so I'm going to put a little question mark in. How could we figure that out? Well, we know we have, on this semicircle, we have 45 degrees and 50 already. So well, I think I can do that in my head. That's 90. Lost some paper. 95, sorry. And then, since we know this whole thing is 180, I'm going to do 180 minus 95, which is going to give me, hold on, I just want to make sure I do this math right for you guys. 180. Always better to check in your calculator than get it wrong, which is 85. So if we look at this picture, we know this arc up here is 85 degrees. So to figure out R to T, we're going to take the measure of R to T. We're going to take 85 and 50, and that's 135. Oops, sorry, you guys couldn't see that. And that sort of makes sense because it looks like R to T is bigger than 90. All right, if we look at our next example, we have a picture over here, and these are inscribed angles. So we're asked to first find BAC, which is this angle right here. I'm going to see where it opens up to. It opens up to 60. So half of 60 is 30. That's easy peasy. And then here, now this is the opposite. I'm opening up 70. If I take twice of 70, right, I want to double when I go from an interior to the arc outside. That's going to be 140. Okay. All right, now these two are a little bit trickier, and we did do a day of these, so Victor, can you help us? Got this, guys. So if I look here, I have an exterior angle that's 35 degrees. So if we remember our formula, I'm going to start by putting 35 in. I'm going to keep the half, and then we're going to do the big minus the small arc. So 150 minus 35. Okay. Oh, not 35. X, I'm sorry. Our minor arc, so this is our big arc is 150, our small arc is X. So let me put X in here. So in order to solve this, we're going to multiply both sides by 2. First to get rid of that. So 70 equals 150 minus X. I'm going to take away 150 from both sides. And I get negative 80 equals negative X, which is okay because a negative divided by a negative gives us X is 80. Oops, sorry, I'm trying to keep that. And then if we look at this one here, this one's a little bit sneaky because if you notice, we don't have this arc right here. This is our small arc. So if I'm doing X is the exterior angle, half 230 minus, what is this arc here? Well, we know the whole circle all the way around is 360. So I can do 360 minus 230, and that gives me 130. Okay? So if you go ahead and solve this out, you're going to get that X is 50 degrees. Okay, moving right along. We have our area of a sector. So we're asked to find this sector piece. Remember, a sector is just sort of a section. And what we're going to do is plug in. So I'm going to put in my degrees. We have 120 degrees over 360 times pi, and then our radius is 3. So again, I want to review how to do this. The directions ask for 2 ways in your graphing calculator, using in terms of pi and rounding to the nearest hundredths place. So I'm going to go to my fraction, alpha y equals, enter, 120 over, oh boy, 360. And then second pi, and then I'm going to put in my 3 squared. Okay, so when I do that, that's going to give me 9.424. So I want to do the hundredths place, so that's the 2. I look back, it's not going to push it up. Now that's to the tenths place. So 9.24. We want to also write this in terms of pi. So the trick is, if you want to write in terms of pi, I'm going to just do my enter trick here. I'm going to go over and I'm going to just delete this pi. I don't need it because I want to keep the pi in. So our answer here is just going to be, or 3 pi. So remember, in terms of pi means you keep the pi. To the nearest hundredths means you do the second place. So if we look at our second page of notes, lullaby, how do you think we're doing? Yeah, I think we're doing great. This guy's got this down. Okay, now we're looking at the arc length of j to k, which is 45. So I already have my formula written. So we're going to do 45 over 360 times 2 pi, and then the radius is 8. So again, if we were writing this in terms of pi, we probably first want to save ourselves a little time. Alpha y equals, I'm going to type in 45 over 360. Okay, that's our fraction, the part of the arc we want to find, times 2 times 8. So that gives us just a good old 2. So 2 pi would be part of our answer. Sorry, guys. But if we wanted to do 2 times pi, we would just put that in our calculator. 6.28. And again, I'm going to look behind. The 3 is not going to round that 8 up. It's just going to keep it good old 8. So our other answer would be 6.28. Okay, and last but not least, my dears, we got this. We're in the home stretch. Sorry, Victor's sitting on all my markers. Come on, Victor. So we're going to turn in example 6 and 7. We're going to convert between radian degrees. So if we look at this, we have pi over 180. If we're converting to radians, remember the pi or the radian goes in the top and the degrees goes in the bottom. So times pi over 180. And then I don't think that we showed you guys this on the calculator, but an easy way to do this, to do 60 over 180, I think 60 over 180 is pretty easy, but 60 divided by 180, and then if you guys remember, this is my favorite button on the fraction, 0.3, math, frac, it turns it into 1/3. So our answer here is 1/3 pi. Okay, so why don't you guys try B and C right now, and I'll pause the video and show you guys my answers in a second. Okay, so just to check our work, 150 divided by 360 is going to be 0.4. I'm going to math frac that, and I get 5/12 pi. And then same thing here, I'm going to do 220 divided by 360, and I'm going to math frac that, and that's 11 over 18 pi. Bada bing, bada boom. We got this. All right, now, last but not least, my loves, we have degrees. We're going to convert into degrees. So look, my 180 is going to be on the top, and my radian, oh, that's a really big degree, sorry. It's going to be on the bottom. So I'm going to take pi over 6, multiply it by 180 over pi. Now, what's great about this is the pi's should, adios, sayonara, cancel. 180 divided by 6 is going to leave us with 30, and make sure you have your degree sign. Okay, so same thing with this. 2 pi over 5 times 180 over pi. So first we're going to cancel out our radian signs, and then I'm just going to multiply 2 times 180. So right when we multiply fractions, we multiply across. 2 times 180 divided by 5 is 62 grados. Okay, 72 degrees. Entonces, 4 pi over 5 times 180 over pi. Again, first thing first, I'm going to cancel out these radians. And then on my calculator, I'm going to do 4 times 180 divided by 5 again. Well, that's silly. And that's 144 degrees. Okay, that's it for circles. End it, done. Victor, what do you think? Can you squash our circles unit? Squash, squash, squash. Nom, 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 nom. All right, say goodbye to Lullaby, guys. Bye-bye. Have a great day. We miss you. Keep up the hard work.